Here we are on page 8 of Trig Equations and Identities Addendum. I noticed that I didn't leave enough space for this problem here. Okay? Alright, I'm sorry about that. We do need to know this trig identity to do these problems. The first thing it says is, show that cosine of the two angles added together plus the cosine of the two angles subtracted is equal to 2 times the cosine times the 2 times the two cosines multiplied together. So we know we're going to use this identity here. And so first what we're going to do is we're going to say, okay, the first expression is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. We just used this expression. Then we're going to look at the subtraction one. And so for this one, we know that it looks very similar, except instead of minus sine A sine B, we're going to do plus sine A sine B. And then we're going to simplify. So do you see how this and this are opposites and they're going to cancel each other out? So that would leave us with 2 cosine A times cosine B. And so that's exactly what we're supposed to show. And since we don't have very much room, I am going to take this and I'm going to put it down here. Okay, I'm just going to store it here. And then we'll put it somewhere else later. Okay. Next thing, show that cosine A times cosine B is equal to this plus this. Okay. So the way we could do that maybe is we could multiply this times 1/2, right? So we could say we're going to multiply both sides by 1/2. So the left side would be multiplied by 1/2, and we get 1/2 cosine of A plus B plus 1/2 times the cosine of A minus B is equal to 1/2 times 2, which would just be 1, cosine A cosine B. And that's exactly what we're supposed to show. So I don't even see much reason to save this one because we didn't hardly do any work, so I'm just going to erase it. Okay, C. Hence, write the following as a sum of cosines. Okay, first thing we're going to do is we're going to do cosine of 4 theta times the cosine of theta. Okay, so cosine of 4 theta times cosine of theta, that kind of looks like this, right? So this is equal to 1/2 times the cosine of these two added together, which would be 5 theta, plus 1/2 times the cosine of the two subtracted, so it would be 4 theta minus theta, so that would be equal to 3 theta. So it would be 1/2 cosine 5 theta plus 1/2 cosine 3 theta. Let's do this one now. So this one says 2 cosine of an angle times cosine of another angle. That kind of looks like this. So I can rewrite it with these two, right? I could put cosine of 3 beta plus beta, which would be 4 beta, plus cosine of 3 beta minus beta, which would be 2 beta. Okay, now we have 3 cosine P times cosine 4P. This kind of looks like this one, except for it's multiplied times 3. What if we just multiplied each one of these by 3, and we'll get 3 halves of this and 3 halves of this, okay? So we'll have 3 halves of cosine of P plus 4P, which is 5P, and we will have 3 halves of cosine of P minus 4P, which is cosine of negative 3P. Now, we could have avoided the negative sign by just like switching these two, but remember that cosine of a negative angle is actually the same thing as the cosine of the positive angle that is reflected over the x-axis. So actually cosine of negative 3p is the same thing as cosine of 3p. So we could just rewrite it like that. Cosine of 5p plus 3 halves times cosine of 3p. Okay, and then, actually, maybe we did have enough space. So we'll just bring this back up here. Okay, last problem on this page. Oh my gosh, it's a doozy. The products to some formula are, and they give us these 3 formulas. What formulae result if we replace b by a in each of the formulas? Okay, let's try that out. So we'll have a, and we are going to take b's and we're going to replace them with a's. So we're just going to get sine a cosine a equals 1/2 times the sine of 2a plus 1/2 times the sine of a minus a, which is sine of 0, which is just 0. So, we're actually going to get the double angle formula. To adjust it, we will take the 1/2 and multiply by 2, so we'll get 2 sine of a cosine of a is equal to sine of 2a. Okay? What about b? Cosine a cosine b. So instead of cosine a cosine b, we're going to have cosine a times cosine a, which would be cosine squared a equals 1/2 times the cosine of 2a plus 1/2 times the cosine of a minus a, which is cosine of 0, which is 1. So instead of 1, we're going to have 1/2. Okay? And so now we have cosine squared of a equals 1/2 cosine 2a plus 1/2. So actually, what we're going to get here, if we multiply everything by 2 and move the 1/2 to the other side, we're going to get the double angle formula for cosine, which is going to be 2 cosine squared a minus 1. C. So we're going to have sine a times sine a, which is sine squared a. That's equal to 1/2 cosine a minus a, which is 1/2 cosine of 0, which is 1. So it's 1/2 minus, and then cosine of a plus a is cosine 2a minus 1/2 cosine 2a. And we're going to get the double angle formula for cosine again. So in this case, we're going to move the cosine 2a to the left because it's negative here, we want it to be positive. We keep the 1/2 here, and then we subtract the sine squared a over to here. We have 1/2 minus sine squared on the right. Then we're going to multiply everything by 2 so that we get cosine 2a instead of 1/2 cosine 2a. And then we'll have 1 instead of 1/2, and we'll have 2 sine squared instead of sine squared. So we just get the other double angle formula for cosine. Now let's read on. B. Suppose that a plus b equals s and a minus b equals d. Show that a equals s plus d divided by 2 and b equals s minus d divided by 2. Okay, so first what we're going to do is we're going to start out with this formula here, and we're going to put a on the left and we're going to put everything else on the right. So we'll have a equals s minus b. Then we'll take this formula and solve for b. So we'll have b equals a minus d. And then we're going to substitute b equals a minus d in for this b. So we'll get s minus a minus d, which is equal to s minus a plus d. Now we are going to subtract the a to the other side, and we'll have 2a equals s plus d. So a is equal to s plus d divided by 2, right? And that's what we wanted. Now let's try to do it the other way. Let's solve for b for this equation here. We have b equals a minus d, right? Then we say, okay, what's a? A is equal to s plus d divided by 2, so let's substitute that in. S plus d divided by 2 minus d is equal to s minus d divided by 2. And that's the other one we want. Okay, so we finished that. Now, using the substitutions a plus b equals s and a minus b equals d, show that equation 1 becomes this. Okay, so equation 1 is this one here. And so let's add or substitute a plus b s equals s and a minus b equals d. So we would have this become s, this become d, right? And then sine a cosine b would be this times cosine of that, right? So let's do that. We'll have sine of s plus d divided by 2 times sine of s minus d divided by 2 is equal to 1/2 times the sine of s plus 1/2 times the sine of d. 1/2 times the sine of s plus 1/2 times the sine of d. And now let's check to make sure this is exactly what we wanted. Sine s plus sine d equals 2 sine of that times cosine of that. Yeah, all we need to do is multiply everything by 2, and then we're fine. Let's make more space. Oops. Okay. So, let's multiply by 2. So we'll have 2 sine of s plus d divided by 2 times the sine of s minus d divided by 2 equals sine of s plus sine of d. And we got what we wanted. Now it says, by replacing d by negative d in 4, show that sine of s minus sine d equals blah, blah, blah. Okay, so instead of d, I'm going to put negative d, so that would be 2 sine of s minus d divided by 2 times the sine of s plus d divided by 2 is equal to the sine of s plus the sine of negative d. Sine of negative d is actually equal to the negative sine of d. So the sine of s is minus the sine of d. Okay. So now we have this. Okay. Do you see how the left side did not change at all because all we did was switch the positions of s minus d, s plus d, and that doesn't really change anything? Okay. Let's make some of this stuff smaller. We have time to do the last, we have space to do the last step. Okay. What formula results when the substitution a and b is made into 2? Okay. 2. So 2 is the cosine formula. So we have cosine of a times cosine of b equals 1/2 times the cosine of the sum plus 1/2 times the cosine of the difference. Okay. So now we're going to have cosine of s plus d divided by 2 times the cosine of s minus d divided by 2 equals 1/2 times the cosine of s plus d divided by 2 plus, I think it's plus, 1/2 times the cosine so the first one would be a plus b. When I do a plus b, that would be this plus this. So that would give me s divided by 2 times 2 because the d's would cancel each other out. So that would just be s. And then the other one would be the first one minus the second one. So it would be s minus s, which would cancel out, and it would be d minus negative d, which would be d plus d, which would be 2d, and so that would be d. Let's shrink this down and go to the next one. Oops. Okay, I'm going to put it right there. The next one, it says, what formula results when we put a equals blah, 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 and b equals blah, blah, blah into equation 3? Equation 3 is this one here. It's going to be sine of one angle times the sine of the other angle, 1/2 of the cosine of the difference minus 1/2 times the cosine of the sum. So that would be sine of s plus d over 2 times the sine of s minus d over 2 equals 1/2 times the cosine of the difference, right? 1/2 times the cosine of the difference, which would be s plus d minus s minus d. So the s's would cancel out and the d's would double. So we get d minus 1/2 times the cosine of the sum. The sum would be the s's would double and the d's would cancel out, so we would end up with s.